Ever pondered why we stay firmly planted on the ground instead of floating around aimlessly? Or why a speeding car doesn't just stop abruptly without a force acting upon it? Well, these questions find their answers in the 3 fundamental laws proposed by Sir Isaac Newton, laws that form the foundation of classical physics. We'll begin our journey with Newton's first law, also known as the law of inertia. Picture a hockey puck sliding on a perfectly smooth ice surface. The puck will continue to slide almost indefinitely unless an external force acts upon it. This is the essence of the law of inertia. An object at rest tends to stay at rest, and an object in motion continues to stay in motion, unless acted upon by an external force. Next up, we have Newton's second law, which tells us how the velocity of an object changes when it's subjected to an external force. Think of it like this. The heavier the object, the more force you'll need to change its motion. This law is often written as F equals m times a, where F is the force applied, m is the mass of the object, and a is the acceleration. Finally, we arrive at Newton's third law, the law of action and reaction. For every action, there is an equal and opposite reaction. This law explains why you move backward when you release air from an inflated balloon, or why a rocket propels forward when it ejects hot gases out of its rear end. Together, these 3 laws govern the motion of objects we see around us, from a tiny bouncing ball to mammoth celestial bodies orbiting in space. They help us understand why things move the way they do and predict how they will behave under various circumstances. To recap, Newton's first law, the law of inertia, states that an object will remain at rest or in uniform motion unless acted upon by an external force. The second law provides a calculation for force, which is the mass of an object multiplied by its acceleration. Lastly, Newton's third law tells us that every action has an equal and opposite reaction. In the grand realm of physics, these laws are akin to a compass, guiding us through the complexities of motion, force, and momentum. They may seem simple at first glance, but their implications are profound and far-reaching, shaping our understanding of the physical world. So, the next time you see a car halt to a stop or a ball bounce off a wall, remember, there's a bit of Newton's wisdom at play.